wherever we find life.
Left.
We don't fire a rocket motor all the way to Mars. We don't need to. We just place the spacecraft on a trajectory.
Atmospheric entry in 3, 2, 1. Mark. We are awaiting confirmation the parachute has deployed.
Step back before forward to the Europa mission in handful of years. The rover does boost land 2,113 miles from the center of Mars and ends in a safe state.
Spacecraft reporting that heat shield has indeed jettisoned.
Lander separation event has been detected.
Spacecraft reporting lander is separated, moving at a speed of 173 miles per hour. We are near our terminal velocity. Expected retro rocket ignition on my mark. Mark. At this point in time, we should be on the ground.
The rover does boost land 2,113 miles from the center of Mars and ends in a safe state.
The spacecraft has to survive all the bounces for landing to be a success.
No signal at the moment.
Stand by.
First thing we have to do after we land is open our solar panels to the sun so we'll have some power. This charges up the batteries. After that, we can deploy the camera mast so the rover can see, and deploy the antenna so the rover can talk to us.
Sorry. Exploring and back before forward. Here is the landmass comparison to Earth.
Europa is a fascinating object. If you imagine descending onto a world that looks every place like the frozen wastes of the Arctic or the Antarctic, you get a pretty good impression of what's going on. It's very, very bright, because the ice is very reflective and broken up in places where it looks like you have basically ice rafts on the surface. It would be like flying over a moon-sized ice field, basically. And landing on the surface, you would not see any large mountains. You would see crisscrossing ridges that would look like killer ski slopes every place.
Killer ski slopes with pale pink stripes, and all with the icy surface at a very cool 260 degrees Fahrenheit below zero.
So if the ice is so...
In Europa we need newer, faster rockets, more advanced technology that will land on Europa's thick sheet of ice, melt though down, then convert to submarine mode, where it will do a quick underwater Europa study. For example, around 2020 we see here the Europa Clipper landing. Deploys, out comes the cryobot which melts through then sinks through that 30-kilometer of ice first, before it...
Very bizarre place, and really stretches our minds to think about what's possible in an ice world that's orbiting a giant planet like Jupiter.
Europa itself is stretched by the gravitational strain of being locked in an orbit with Io and Ganymede around its giant host.
Every Europan day, as it orbits Jupiter, the stresses rotate around. And if a crack forms moving at just the right speed across Europa's surface, about the speed a person can walk, it would follow a curved path and explain the pattern that we see on the surface. It'd be able to hear the cracking, probably, of Europa's ice shell.
The processes that heat Io are operating on Europa as well, but on a less dramatic scale. And so
a moon of Jupiter sitting well outside of the Goldilocks zone is kept warm, not from energy sources traceable to the sun, but from what we call the tidal forces of Jupiter itself. So Jupiter and surrounding moons are actually pumping energy into Europa. You want to hit it around a few times. You are literally warming up the ball. It's not just simply let's get loose. You are literally warming up the ball. How? You are distorting it every time you smack it, and then the resilience of the ball pops it back into shape. And every time you do that, every smack, it's not fundamentally different from what's going on in orbit around Jupiter. So you have this frozen world, Europa, completely frozen on its surface. But you look at the surface, and there are cracks in the ice. There are ridges in the ice where there's a crack, and it shifted and then refroze. So this ridge has a discontinuity in the crack and then continues in another place. So what this tells you is that Europa cannot be completely frozen. Because if it were, nothing would be moving. You look at the surface of Europa, the frozen surface, they're like ice chunks that are like shifted and refrozen and shifted again.
I think the best model for this is kind of like a tree root growing beneath an asphalt sidewalk and pushing it upward to make a double ridge and break the cold, brittle ice on Europa. And it may be because that stretching creates cracks, and then those cracks, there's movement back and forth, and that back and forth movement creates heat, and that warm ice wants to rise up. So there are a lot of different ways scientists have thought of to explain these ridges, and really going there and understanding the geological relationships close up.
there's constant changes in Jupiter's gravitational pull that are distorting the surface, and that's generating heat in the interior.
What this means is, not only do we have a source of heat outside of the Goldilocks zone, we have conditions under which life could be thriving. And knowing that this is possible has completely broadened the net.
The ocean of Europa is thought to be over 60 miles deep, deeper than any on Earth. If so, there is more water hidden on Europa than on our own blue planet. And tempting us, and with water, comes the possibility of life.
This sounds like a place where life might exist, oceans. I have friends in the oceanographic community that want to get wet right now. It says, drill me a hole, I can get it,
with water comes the possibility of life.
It's like a place where life might exist.
Who are starting to think about what it really takes to melt into Europa's ocean. What kind of autonomous vehicle could make its way through ice and then swim around that ocean, find interesting things, and report that back to the surface, and then beam it back to Earth.
Bill Stone has gone where no man has gone before. A pioneering cave diver and aerospace engineer, he now wants to go diving in an alien ocean some 500 million miles from home. And he's developing the technology to do it.
We started off with the idea of two things. One is this gadget that swims has to be intelligent enough to understand where it is. What we wanted to create was a field microbiologist on silicon that did everything that a good microbiologist would go out and do in the field.
His Depth X and Endurance Intelligent Autonomous robots have already proven themselves as very capable explorers in impossible underwater situations. Mapping deep subterranean caverns in Mexico, and now exploring deep below ice-covered lakes in Antarctica. As these robot submarines accomplish great missions, the possibility of one day melting our way into Europa's deep ocean is moving from fiction toward fact.
Let's just imagine that we're on a little spacecraft with the capability to melt through the ice. We push down, boom, plowing through the ice. We hit the water. That may be an interesting zone, right there at the interface between the water and the ice. When we look around, what we might see is a community of organisms that are growing on energy that's coming through the ice, oxidants, maybe even oxygen, produced by sunlight on the surface of the ice being mixed through the ice, reacting with the water, and at that interface, energy is being released. Organisms are consuming that energy. Okay, that's cool. We can go deeper down to the bottom of the ocean. There we see maybe hot hydrothermal vents, deep sea vents like we see on Earth, where tidal energy, which is being caused by Jupiter's gravitational pull, is pumping hot fluids through the crust. That's what we'd be hoping to find.
On Earth,
wherever we find liquid water, we find life.
That is extremely important. If Europa is an environment where we think there should be life, then it's important to know, is there? Does life get going easily given the right conditions? Or, for that matter, if there's no life in Europa's ocean and the conditions are favorable to life, why not? And how rare then is life as we know it on Earth?
it's far out and far away and tempting us to visit.
Hard to wrap your head around, but that's okay. It's easy to get lost in the vastness of it all. And sometimes, it's fun to do before pulling things back into our reality here on Earth.